The massive view screen aboard the Galactic Council's observation station, filled with the dim red light of a dying star. Around the circular chamber, representatives of 1,000 species watched in silence. Some floated in anti-gravity fields, others stood on various gravity-adjusted platforms, but all eyes focused on the strange structure that orbited the failing sun. "Another star enters its death phase," announced first observer Smith, the human representative. He stood on the main platform, feeling somewhat out of place among the advanced species. Even after 50 years of Earth's membership in the Galactic Council, humans were still seen as newcomers. The structure that caught everyone's attention was enormous, a ring-shaped machine that spanned roughly the same distance as Mercury's orbit around Sol. Its surface gleamed with a dull, ancient metal that had weathered countless centuries of stellar radiation. Massive arms extended from the main ring toward the dying star, like the spokes of a giant wheel. "This is the 7th such star engine we have found," said Senior Council Member Gray, a tall being who looked almost human except for their silver skin. "Like the others, it refuses our attempts to reactivate it. The star will die within the next 1,000 years without intervention." Smith studied the technical readouts floating beside the main display. The numbers told a story that made his engineering background itch with curiosity. "How many species have attempted repairs?" 1,008 attempts over 12,000 years, Gray replied. Their voice carried a note of resignation. Each species brought their most advanced technology, their brightest minds. All failed. The chamber erupted in murmurs as various representatives discussed among themselves. Smith kept quiet, his eyes fixed on the readouts. Something about the engine's basic structure looked familiar, but he couldn't quite place it. "As is tradition," Gray continued, raising their voice above the murmurs, "we extend an invitation to Earth to attempt repairs. While we don't expect, we accept," Smith interrupted, causing several nearby representatives to vibrate in surprise, their equivalent of aghast. Gray turned their silver face toward Smith. "You understand this is merely a diplomatic courtesy. Your species' technology level is—" They paused, searching for a diplomatic word. "Developing." Smith nodded, his eyes still fixed on the readings. "We have someone in mind. An engineer. His name is Jack." "Jack." Gray repeated the simple name with something like disappointment. "Not Dr. Jack. Professor Jack." "Just Jack," Smith replied. "He fixes things, old things mainly, has a gift for it." The chamber filled with the equivalent of laughter from various species. A floating crystal being chimed in amusement. "You would send a repair technician to solve what our greatest scientists could not." Smith finally looked up from the readouts. "Sometimes you need someone who knows how things break to figure out how to fix them." Gray's silver skin rippled, a sign of resignation. "Very well. As per protocol, you have 1 standard month to transport your engineer to the site. The Council will provide all previous repair attempts documentation and full access to the structure." As the various representatives began to leave the chamber, Smith pulled out his communication device. The simple action drew more amused looks. Many species use direct neural links for communication. He typed a quick message to Earth. "Found something interesting. Old engine. Really old. Nobody can fix it. Interested?" The reply came less than a minute later. "Send specs, and tell me it has actual nuts and bolts. Sick of quantum neural interfaces and self-repairing nanomaterials. Jack." Smith smiled as he looked up at the massive engine on the view screen. Something told him this was going to be interesting. As the dying star cast its red light across the chamber, he typed back, "You're going to love this one. It's old. Really old. And I think it might just need someone who understands the basics." Jack stared out the viewport of the Council transport ship as it dropped out of faster-than-light travel. He wore his old brown work jacket, complete with burn marks and grease stains, which had drawn curious looks from the ship's crew. A worn toolbox sat at his feet, filled with what the Council members had called primitive implements. The dying star filled half the viewport, its angry red glow making the ship's interior look like an old darkroom. But it wasn't the star that made Jack's breath catch in his throat. It was the engine. The ancient machine was beautiful in a way that only an engineer could appreciate. Its massive ring structure looked like the world's biggest bearing assembly, slowly turning around the dying sun. "Impressive, isn't it?" asked the ship's navigator, a being made mostly of light who called himself Blue. "The greatest minds in the galaxy have failed to understand its workings." Jack pulled out a paper notebook. Actual paper, which had made several crew members titter in amusement, and started sketching. "Looks like a big radiator to me," he said quietly. "A what?" Blue's light dimmed slightly in confusion. "Never mind," Jack muttered, his pencil moving quickly across the paper. The basic shape was familiar, reminding him of something he'd seen in an old engineering textbook. The ship docked with one of the engine's maintenance platforms. As Jack stepped out, carrying his toolbox, he was met by a group of council scientists. Their leader, a tall, silver-skinned being, stepped forward. "I am Gray, senior council member," they said. "We have prepared the quantum interface chamber for your analysis. Our most advanced AI systems are ready to assist with translations of the control systems." Jack wasn't listening. He had walked to the platform's edge, protected by force fields, and was looking at a massive warning sign etched into the engine's surface. The holographic message flickered in dozens of dead languages. "What do the warnings say?" he asked, still sketching in his notebook. "A floating crystal being hummed to life. We have spent centuries decoding them. They speak of critical system failures, quantum state collapses, and—" "No," Jack interrupted, pointing at a simple pictogram below the text. "That. The simple picture." The crystal being paused. "Oh, that is too primitive to be important. A mere maintenance marking." Jack smiled. The pictogram showed a simple diagram. 2 lines representing pipes, arrows showing flow direction, and what looked like a universal symbol for heat exchange. He'd seen similar markings in old Earth power plants. "Show me the maintenance tunnels," he said. "But the control center," Gray started. "Tunnels first," Jack insisted. "Need to see how she breathes." The council members exchanged confused looks. "How it breathes?" Blue asked. "Figure of speech," Jack said, already walking toward a massive doorway. "Where I come from, you don't start with the brain if the heart isn't pumping right." The maintenance tunnel was huge, big enough to fly a small ship through. Jack's boots echoed on the metal floor. Real metal, not the quantum-engineered materials he'd seen on the council ship. His flashlight beam revealed pipes the size of buildings running along the walls. The air smelled like ozone and hot metal. "Perfect," he whispered, running his hand along a wall. The metal was warm. "She's not dead, just sleeping." Behind him, Gray spoke quietly to another council member. "The human appears to be talking to the machine." "All good engineers talk to their machines," Jack called back, not turning around. "Only way to learn their stories." He stopped at a junction where several massive pipes met. More pictograms covered the walls, telling a story in simple mechanical terms that any Earth engineer from the last 300 years would understand. Jack grinned as he made another sketch. "Well, old girl," he said softly, patting one of the huge pipes. "Let's figure out what's really wrong with you." Deep in the engine's maintenance tunnels, Jack sat on a metal beam, eating a sandwich. The council members had been horrified at the idea of bringing organic sustenance into the ancient machine, but Jack had insisted. Good work needed good fuel, he told them. His notebook lay open beside him, its pages now filled with rough sketches and calculations. Above him, a pipe bigger than an ocean liner creaked as something moved inside it. The sound echoed through the massive chamber like a whale's song. "There you are," said Blue, floating into the chamber. "The quantum analysis team requests your presence. They found something in the control systems." Jack took another bite of his sandwich, chewing thoughtfully. "Tell me something," he said after swallowing. "In all those repair attempts, Did anyone ever measure the temperature difference between these two main pipes? Blue's glow flickered in confusion. The quantum state of the... Not the quantum stuff, Jack interrupted. The actual temperature. Heat. The thing that makes water boil. That's far too basic, Blue said. These systems operate on principles far beyond simple thermodynamics. Jack stood up, brushing crumbs from his jacket. He walked to one of the huge pipes and pressed his hand against it. Then he walked 30 feet to the parallel pipe and did the same. This one's hot, he said, pointing to the first pipe. That one's cold. But according to these old maintenance markers, it should be the other way around. Gray appeared at the chamber entrance, their silver skin reflecting Jack's flashlight. The human continues to fixate on maintenance markings while ignoring the sophisticated control systems. Jack pulled out an old thermal scanner from his toolbox. The device was simple compared to Council technology, but it gave clear readings. He pointed it at various parts of the pipes, nodding to himself. "You've got expansion joint failure," he announced. The Council members stared at him. "Impossible," Gray said. "The quantum stabilizers." "Look," Jack interrupted, pulling out his notebook. He flipped to a clean page and drew a quick diagram. "Imagine you've got a garden hose in the sun. What happens?" What?" Blue asked. "It gets hot, it expands," Jack continued. "Now imagine that hose is miles long and made of metal. You need special joints to let it expand and contract, or it'll tear itself apart." He walked along the pipe, his flashlight beam revealing a series of massive metal rings spaced every few hundred feet. "These are expansion joints. Really big ones. And they're stuck." Gray's skin rippled with skepticism. The engine's failure is clearly more complex than simple mechanical. A deep groan cut through the chamber, making the metal floor vibrate. Jack nodded as if the engine itself was confirming his diagnosis. "When these joints get stuck, the pipes can't expand properly with heat," he explained, sketching more diagrams. "That makes the hot side too hot and the cold side too cold. The whole heat exchange system goes out of whack." He closed his notebook and looked at the Council members. All those fancy quantum computers. They're just the engine's brain. But right now, its joints are frozen with age, like arthritis in a giant. "And you believe you can repair this arthritis?" Gray asked, their tone somewhere between mocking and curious. Jack grinned. "On Earth, we've been dealing with thermal expansion in machines for centuries. Sometimes the oldest problems need the oldest solutions." He reached into his toolbox and pulled out a large wrench. The metal gleamed in his flashlight beam. "I'll need about 1,000 of these in various sizes," he said. "And some high-temperature lubricant. The kind they use in old-style fusion reactors." "That's absurd," Gray protested. "The solution cannot be so primitive." Another groan echoed through the chamber, louder this time. Jack patted the huge pipe beside him. "She doesn't need quantum physics right now," he said softly. "She just needs someone to help her move again." In a small maintenance room that the Council had converted into his temporary office, Jack sat surrounded by holographic displays of ancient texts. His notebook was open on the metal desk, its pages now dog-eared and stained with coffee. He'd been studying the engine's original maintenance logs for 3 days straight. The door slid open, and Smith, the human representative, walked in. "The Council is getting impatient," he said, looking at Jack's cluttered workspace. "They want to know if you found anything in the ancient data." Jack held up a hand, his eyes fixed on one particular hologram. The image showed a simple series of pictograms, drawn like a child's step-by-step guide. "Look at this," he said. "It's beautiful." Smith leaned in. "Those are maintenance instructions. The simplest ones I've ever seen," Jack replied, excitement creeping into his voice. "The beings who built this engine, they were geniuses, not because they made it complicated, but because they made it simple." He stood up and walked to a large diagram he'd drawn on the wall. It showed the engine's basic structure, with arrows indicating flow directions and temperature changes. Every species that tried to fix this thing focused on the quantum computers, the advanced materials, the complex stuff, Jack explained. But look at the core design. He traced a line across his diagram. It's just a really big heat pump. Smith frowned. A heat pump? Like in an air conditioner? Exactly. Jack grinned. The quantum computers just control it. The real work is done by basic thermodynamics. Heat flows from hot to cold, pressure differences create movement, and the movement generates energy. The door opened again, and Gray entered with several other council members. The human has spent 3 days examining maintenance logs meant for basic service workers, Gray announced, their tone dismissive. Meanwhile, our quantum experts have made no progress with the control systems. Jack turned to them, holding up his notebook. Your quantum experts are trying to debug software while the hardware is broken, he said. Look at these maintenance logs. The original builders left instructions so simple that anyone could follow them. He pointed to another hologram, this one showing a series of temperature and pressure readings. These numbers tell a story. The engine's been slowly breaking down for thousands of years. Not because of quantum failure, but because of good old-fashioned wear and tear. Blue floated forward, their light dimming in concentration. But the quantum state readings are perfect, Jack interrupted. The computers are fine. They're just sitting there waiting for the mechanical systems to work properly again. He walked back to his diagram. It's like having a perfect dragger in a car with flat tires. Doesn't matter how good the dragger is if the wheels won't turn. Gray's silver skin rippled with what might have been irritation. You suggest we ignore the quantum systems entirely. For now, yes, Jack said. He flipped through his notebook until he found a particular sketch. The original builders knew this might happen. That's why they left these maintenance logs. They're not just instructions. They're a message. A message? Smith asked. Jack nodded. They knew that someday their engine would need fixing. And they knew that advanced civilizations might overthink it. So they left instructions that anyone could understand, no matter their technology level. He held up the hologram with the simple pictograms. This isn't primitive technology. It's brilliant engineering. Make it so simple it can't break badly. And when it does break, make it easy to fix. The room fell silent except for the distant hum of the dying engine. Finally, Smith spoke. So what do we do next? Jack closed his notebook and picked up his toolbox. We follow the instructions, step by step, just like they wrote them. No quantum physics required, just good old-fashioned elbow grease. Gray's skin flickered with multiple colors, a sign of strong emotion. The council will not approve. The council, Jack interrupted quietly, has tried their way 1,000 times. Maybe it's time to try the simple way. The council chamber buzzed with nervous energy as Jack stood before the assembled representatives. His old work jacket looked out of place among their shimmering robes and energy forms. Behind him, a massive hologram showed his hand-drawn diagrams of the engine's mechanical systems. The problem is simple, Jack began, holding up his notebook. The engine works like a giant refrigerator. It pumps heat from one place to another. But right now, its pipes are stuck. They can't expand and contract like they should. A crystal being chimed in disagreement. Impossible. Our quantum scans show. Here, Jack interrupted, pulling out his thermal scanner. He projected its readings onto the main display. Red is hot, blue is cold. See these points where red meets blue too sharply. Those are the stuck joints. Gray stepped forward, their silver skin reflecting the hologram's light. You propose to repair a star engine using mechanical tools. Jack nodded. The original builders left us everything we need to know. He pointed to his translated version of the maintenance logs. Step 1. Release the stuck expansion joints. Step 2. Realign the flow regulators. Step 3. Let the quantum computers do their job. And how do you plan to release these joints? Blue asked, floating closer to examine the diagrams. Jack grinned and pressed a button on his datapad. The chamber's doors opened, and a procession of robots rolled in, each carrying tools that looked like they belonged in an old Earth factory. "We heat them up," he said. "Then we cool them down. Then we give them a good whack with these." He patted one of the large hydraulic hammers. "It's called percussion maintenance." A wave of shocked murmurs swept through the chamber. "You want to hit the ancient star engine with hammers?" someone asked in disbelief. "Calibrated percussion tools," Jack corrected. "Sometimes, when something's stuck, you need to give it a careful tap. Any mechanic knows that." Smith stepped forward from his place among the council members. "I've reviewed Jack's plan," he announced. "The physics is sound. The engineering is basic, but that's what makes it brilliant. The original builders created a system that could be fixed with fundamental tools and knowledge." Gray's skin rippled with concern. "And if this percussion maintenance damages the quantum systems?" "It won't," Jack said confidently. "Look at the engine's design. The quantum computers are isolated from the mechanical systems. The builders knew that the physical parts would need maintenance, so they protected the delicate stuff." He walked to the center of the chamber and held up his original sketch of the engine. "This isn't about advanced technology. It's about understanding how heat moves, how metal behaves, and how to help a machine start moving again." The chamber fell silent as the council members studied his diagrams. Finally, a voice spoke from the back. "How long will this repair take?" 3 days, Jack replied. 1 day to heat the joints, 1 day to cool them, 1 day to realign everything. Then we let the quantum systems restart themselves." Gray conferred quietly with other senior council members. The chamber hummed with tense discussion. After what felt like hours, Gray turned back to Jack. "The council has decided," they announced. "Your proposal is—" They paused, their skin shifting through several colors. "Unorthodox. But we have failed 1,000 times with orthodox methods. You have 3 days." Jack nodded and turned to his robots. "All right," he said, picking up his toolbox. "Let's go wake up this old girl. And somebody get me some coffee. It's going to be a long 3 days." As he walked out, followed by his parade of industrial robots, he heard Smith explaining to a confused council member, "Coffee is a human drink that helps us work better." "Ah," the council member replied. "Another primitive but effective solution." "Exactly," Smith said with a smile. "We humans are good at those." Sweat dripped from Jack's forehead as he worked inside the massive maintenance tunnel. The heat was intense. They'd been applying controlled thermal stress to the expansion joints for 18 hours straight. His jacket lay discarded nearby, and his shirt was soaked through. "Temperature at junction 47 reaching optimal levels," reported Blue, who monitored the readings from a safe distance. The light beam's glow was barely visible through the waves of heat distorting the air. Jack nodded, checking his old thermal scanner. "That's the last one in this section. Time for the fun part." He turned to the line of robots waiting patiently behind him. "Bring in the hammers." The robots rolled forward, each carrying large hydraulic percussion tools. Gray, watching from the observation platform, visibly flickered with anxiety. "This seems barbaric," they muttered. "Sometimes the old ways are best," Jack replied, positioning the first hammer. He checked the ancient maintenance diagrams one more time, making sure the strike point aligned perfectly with the markings left by the original builders. Starting percussion sequence in 3, 2, 1. The hammers activated in perfect sequence, sending carefully calibrated shock waves through the massive joint. The sound echoed through the tunnel like massive bells ringing. The entire section of the engine seemed to shudder. Junction 47 showing microfracture patterns, Blue reported quickly. "The quantum stability is—" A loud groan cut through the chamber, followed by a series of sharp cracks. Gray's silver skin went almost white with alarm. But Jack was smiling. "Listen to that," he said softly. "She's stretching." The cracking sounds continued, but they were changing, becoming less sharp and more like the popping of joints. Jack walked along the huge pipe, running his hand along its surface, feeling the vibrations. Temperature differential is equalizing, Blue announced, surprise evident in their tone. The joint it's moving freely. 47 down, 53 to go, Jack said, wiping sweat from his face. He checked his notebook where he'd mapped out every stuck joint in the system. Next section is near the primary heat exchanger. That's going to be the tough one. The repairs continued for hours. Each joint required the same careful process: heating, precise percussion, and then monitoring as the ancient metal remembered how to flex and move. Jack worked tirelessly, checking and double-checking each step against the original maintenance logs. Some of the council observers had to leave. The heat and noise were too much for them. But Blue stayed, their light form flickering with increasing interest as joint after joint came free. The system's thermal efficiency is improving, they reported after the 40th joint. Overall flow resistance has dropped by 30%. Jack nodded, already positioning robots for the next section. She's remembering how to dance, he said. These old joints just needed a little encouragement. The critical moment came at the primary heat exchanger. This joint was the largest, connecting pipes bigger than Earth's largest ships. The robot's hammers looked tiny next to it. Maybe we should reconsider, Gray began. Trust the instructions, Jack interrupted, pointing to the ancient maintenance symbols. They knew what they were doing. He double-checked his calculations one last time, then gave the signal. The hammers struck in perfect harmony. The sound was deafening, like a giant gong being struck. For a moment, nothing happened. Then, with a groan that shook the entire chamber, the massive joint shifted. Decades of built-up tension released at once. The huge pipes moved, adjusting themselves millimeter by millimeter, finding their natural positions. Primary heat exchanger flow rate increasing. Blue reported excitedly. Temperature differential normalizing across all connected systems. Jack watched as status indicators around the chamber began changing from red to green. The ancient engine was awakening, joint by joint, pipe by pipe. Good girl, he whispered, patting the newly freed joint. I knew you had it in you. The council chamber was silent as the main screen displayed the dying star. 3 days had passed since the last joint was freed. Jack stood at the observation window, his old work jacket clean for the first time in days, his notebook open to its final page. All mechanical systems are functioning within original specifications, Blue announced, their light form glowing brighter with excitement. Quantum computers are initiating startup sequence. Around the chamber, hundreds of displays flickered to life. Ancient systems, dormant for millennia, began powering up one by one. The massive engine's ring structure started to pulse with a soft blue light. Impossible, whispered Gray, their silver skin rippling with amazement. The quantum matrices are accepting commands. They're operating perfectly. Jack smiled, watching as the engine's massive arms extended toward the dying star. Of course they are, he said. They were never broken. They were just waiting for the physical systems to work properly again. The star's angry red glow began to change. Where the engine's influence touched, the color shifted toward a healthier yellow. Energy readings spiked across all monitors. Full system functionality achieved, Blue reported. Star rejuvenation process it's working. The stellar mass is stabilizing. A cheer went up from the assembled council members. Species that had never agreed on anything were celebrating together as they watched the ancient engine do its work. The star was coming back to life. Smith approached Jack, shaking his head in wonder. You did it, he said. You fixed what 1,000 species couldn't. No, Jack replied, closing his notebook. The original builders did it. They created something so brilliantly simple that it could last for ages. All I did was read their instructions and trust their design. Gray floated over, their silver skin now glowing with a rainbow of colors. The council has received 17 requests already, they announced. Other dying stars, other ancient engines. They all want. They paused, as if the words were difficult to say. Human engineers. Jack laughed. Send them mechanics, not engineers, he said. Send them people who understand that sometimes a machine just needs a little love and basic maintenance. But what about the quantum systems? Asked a crystal being nearby. The advanced materials. The complex control interfaces. Those are just tools, Jack explained. Fancy tools, but still just tools. The real work is understanding the basics. Heat flows from hot to cold. Metal expands when it's hot. Simple things that never change, no matter how advanced your technology gets. He walked to the main display and pointed to the engine's maintenance markings. The original builders knew this. That's why they left instructions any species could understand. They knew that sometimes the simplest solution is the best one. The star now glowed a healthy yellow-white, its life extended by thousands of years. The engine hummed contentedly, all its systems working in perfect harmony. We have much to learn from humans, Gray admitted. Perhaps we have become too focused on advancing technology, when we should also remember the fundamental principles. Jack picked up his toolbox. Every good mechanic knows that fancy computers won't help if your basic systems aren't maintained. The original builders understood that. They built something that could last forever, as long as someone remembered how to do the simple things right. As the council chamber emptied, Jack stayed by the window, watching the restored star. He pulled out his notebook one last time and made a final sketch. The engine, the star, and the simple maintenance symbols that had guided him. Good engineering, he wrote beneath the drawing, isn't about making things complicated. It's about making complicated things simple. He closed the notebook and smiled at the bright star. Somewhere out there, other ancient engines were waiting. Other stars needed help. And now the galaxy knew that sometimes the best solutions were the simplest ones. After all, a good mechanic's work is never done.